I'm going to go ahead and go through 3.4, which is taking the quadratic equations that we did in the previous sections and applying some word questions. So I'm just going to go through, I think, one example, and then I'll go through one of the questions from the homework. Let's go ahead and start with this example, and this is in a book, so if you want to follow along there, you can. But a farmer wishes to enclose a rectangular region and 120 feet of fencing, plans on using the barn as one of the sides. So he's going to basically take this barn, and by kindness, this is a picture of a barn, and he's going to basically put a fence going out from there. And we know that these two sides, we don't have to be the same one. So we'll call these sides X, okay? And that'll be the parallel sides. So X represents the parallel sides, where they're the same. What does this represent? It's tempting to call that Y, but remember, if we can keep one variable, that's best. So I know that all three of these lengths add up to 120. So all three of these three lengths, I guess. So this would be 120 feet minus those two x's would give me that. And it keeps everything in terms of one variable, which would be x. Find the area of the region in terms of x. Well, let's see, the area of a rectangle would be length times width. So the area of this rectangle would be the length times the width. Or if we wanted it in more of a quadratic form, we could put negative 2x squared plus 120x. Notice I'm just rewriting that into the quadratic ax squared plus bx plus c. Okay? So that'll be our area. Now I can sit there and I can draw this out. We could find the x-intercepts by just setting this equal to 0. We could have done it by factoring. I know that this is going to have a 0 at 0. If the length of the sides were 0, the area would be 0. Not very helpful for that as well. I could find the other 0 by taking, like I said, this x equals 0 from here. It's already factored, so we know that. And I could take the other second part, the 120 minus 2x, and setting that equal to 0. Solving that, subtracting the 120, dividing by negative 2, we get that x is equal to 60. Okay, so obviously if both of these sides were 60 and 60, there wouldn't be any width of the rectangle, the area becomes 0 again. We only have 120 feet of fence. So if I make two fences back to back that are 60 feet, there will be no space in between. Okay, so these are our two zeros. The first one we got by setting x equal to 0, the second one by setting the other group equal to 0. So I know I'm dealing with a quadratic with a 0 at 0, a 0 at 60, okay? And I know that because the a is negative, this is going to be a parabola opening downward, okay? Before we go on, I take a quick second to say, well, what if I do the point 9, call it 918? What does that mean, right? Well, if x was 9, somewhere up here, the y value would be 218. So the x, remember, is the length of one of these sides. So what does that mean? Well, that means that the length of one of the sides would be 9. So if the first one, if x was 9 on the first one, x would be 9 on the second one, the width would be 120 minus 2 times 9, or 120 minus 2 times 9, or 120 minus 18, or 102. So what is the 918? Well, that would be the area. See, the y value in this equation is our area. The x values are the fencing, specifically the length of the fencing. Okay? So the area would be 9 times 102. The area would be 918. Well, why is this important? Because the next thing it wants to do is to find the maximum area. Well, the maximum of this parabola, the maximum, is going to be the vertex. So if they want the max area, then we're basically wanting to find the vertex of this equation. We can do this one of two ways. We can do it by completing the square, or we can do this by using negative b over 2a and f of negative b over 2a. Or we could use technology. So I guess there are three ways. I'm going to start with this because I think that's going to be our easiest option. Our equation was negative 2x squared plus 120x So yeah, so negative b over 2a, the x value there would be negative 120 divided by 2 times a. That would be negative 120 divided by negative 4. That would be 30. And that should actually make sense. Before we do this by completing the square, I want to make sure that this makes sense, that the vertex would be at 30. Why does that make sense? Well, the vertex should be in the middle of the x-intercepts. You should have done that in the previous lesson. The idea is that the vertex is always, because of symmetry, right in the middle. So if this is 0 and this is 60, the vertex would be at 30. Well, that's still not the maximum area. We just know that the maximum area occurs at 30. What is the maximum area? Well, that's where we take that 30 and we do f of 30. What is f of 30? Basically plugging that into the equation. Negative 2 times 30 squared plus 120 times 30. We'll definitely need some help with that technology. So negative 2 times 30 squared would be negative 2 times 30 squared. Don't like the way that came out, so I'm going to put the square on the outside, even though it doesn't make a difference. Plus 120 times 30. So I'm thinking the maximum area is 1800. Let's see. I can obviously check this by doing, if this side was 30, go back to the original question here. If this side was 30, that would make this side 30. That would make this side what? 120 minus 2 times 30. 120 minus 60. That would make this side 60. So if this was 30 and this was 60, the area would be 30 times 60, or 1800 square feet. Option 2. Option 2 says I'm going to take this equation and I'm going to complete the square. I understand that this won't be the most convenient way, but this is a skill that we're going to be building on in the future chapters where we have to know it, so we might as well focus on it now. What do? We want that a to be 1, we want the b to be even, so I'm going to divide everything by negative 2. A divided by negative 2 equals x squared. What is that now? Minus 60x. To complete the square, I take this group here, I cut that b in half. So this is going to be x minus 30 squared. 30x and 30x will make that 60x. But what else does it make? Well, it makes a 900. We don't have a 900, so I add 900. I give it what it needs to complete the square. Adding that 900 completes this square. If I do it to one side, do it to the other. A over negative 2 plus 900 equals. Now what can we do? Well, we basically solve for a, subtract the 900 over, and multiply everything by a negative 2. That gives me that the area is equal to, the negative 2 becomes the a in this form, and this becomes plus 1800. Well, so what's our vertex? The x is 30. The y value is 1800. The answer didn't change. Just a different way of doing it. Probably not your favorite, but once again, you should be able to do that skill. You can bet on the upcoming test. That'll be something I'll be asking you to be able to do. Show me how to do this specifically by completing the square. Third option, which is more than fair, is like I'm going to ask you to graph this. We already sketched a graph, but you should be able to use technology, and you should be able to make a graph. Our first one, let's see, what was it? Tab negative 2. Is that x squared plus 120x. Now this is not going to give me the region of the graph. This looks like a vertical line, so I'm going to need to mess with the window a bit. Let's go ahead and do window, probably view. No, I think it is window. I'm not just going to zoom out. I'm going to actually choose the settings. What is my minimum x? Well, we already know, basically, it doesn't go any less than 0. That was the first 0. What's the max? I can put it at 60 because I know that's going to end it. If you're not sure, you could put like 100, kind of play with it. I'm going to go ahead and put the 60 because that's going to give me the beginning and the end of our x's. The y, well, what's the y? We don't need to go less than an area of 0. If I want to see the axis, sometimes what I'll do there is I will put like a -2 or -3 just so the axis appears. I think this calculator will handle that. In our area, well, we already know our maximum area was like 1,800, so I'm just going to put 2,000, somewhere a little bit above it. I might have to go back and change that to a negative, but this should give me kind of the window settings. Let's see. Yeah, that gives me everything I need. So here is the parabola. This is kind of like the picture that we sketched. We have a 0 at 0. We have a 0 over here at 60, right? We know the vertex is right in the middle. What if I wanted to use technology to find that out? Menu, analyze the graph. We are looking for a maximum this time. So I do maximum, choose a point before it, choose a point after it, and it gets very excited and goes, look at this, we found it. When x is 30, y is, I don't know why they display the text like that, but basically 1.8 times 10 to the third, or 1,800. If you don't like the way that they display that, you can always add a table. And I can find where x equals 30. See if we can do this. Can you type in a 30 on this? Or you don't have to mess with the settings. The table, put it to choose. Did that work? Table, choose. Maybe I don't know what I'm doing. Table, edit table settings. There you go. You can tell it to ask for the x. If I don't want a whole list, and then I go, I know that its x is 30, and the y value is 1,800. So that's a little nicer to see. So just some options here. So here we are. We're going to go ahead and I think we're done with this question. We'll do one more. This is actually straight out of the homework. Okay. So this is question 22. This is one that you would want to copy over and have in your homework. But for now, put it in your notes. Piece of sheet metal is 2.5 times as long as it is wide. It is made to be a box with an open top by cutting 3-inch squares from each corner and folding up the sides, as shown at the top of the next page. I'm sketched it here. The x represent the width of the original piece of sheet metal. So if the width here is x, what is the length? Well, it says the length is 2.5 times longer than it is wide. So if the width is x, the length is 2.5x. This whole width here is x. This whole length here is 2.5x. What are restrictions on the domain? Okay, what can x equal? Let's see, what do we know? What x represents the width? Well, I know that x can't be 0, right? The idea is that you can't have a width of 0 and take 3 inches off of that. That's not going to work. Can x be 1? Well, if x was 1, could I take 3 inches off? No. The idea is I need to be able to take off at least 3 inches, right? So the domain, we know that x must be greater than 6. How do I know that? Well, I'm going to be taking off 3 inches on the top and the bottom, so I can't take off 6. I need it at least to be bigger than 6. Okay? Let's keep going. All right. What is the area of the base in terms of x? Remember, the idea is that we're going to basically cut all of these out. So all of these are going to kind of go away. I'm just going to figure out how to scribble out. Okay? All of these are going to be going away. And then we're going to fold this up, and this is going to become the walls. These 4 rectangles are going to become the walls of our box. Okay? So the height of the box is going to be 3. What is the area of the base of our box? What's the area of the box here? Well, it's going to be the length times width of the little box. Well, what is the width of the little box? I don't know. But I know that the full length here is x, and I know that we took off 3 on the top and 3 on the bottom. So I'm going to call this x minus 6. Why? If this width is x, this must be 6 less than that. We took 3 off the top, 3 off the bottom. If this whole width here is 2.5, what's the length of this smaller rectangle going to be? The full length minus the 6. So now what's the area of that rectangle? What's the area of that base? It would be x minus 6 times, so where the area of the base in terms of x would be x minus 6 times 2.5 x minus 6. That would be the area of the base, okay? So our volume of the cube is going to be the area of that base, x minus 6, 2.5 x minus 6. That's the area of the base times the height of the prism. We can multiply all this out, and we now have a volume of the base. So it's going to get a little messy, but I think we can handle this. Let's start with this. X times 2.5x, how about 2.5x squared? X times minus 6 would be minus 6x. This would be minus 15x plus 36. Still all times 3. Cleaning it up. Obviously, we can do this in the calculator. I'm just kind of handling the math. This amount minus 21x plus 36 times 3. So how about 7.5x squared minus 63x plus 108. And if I made a mistake, feel free to let me know. I do that sometimes. Normally when I do this in class, people catch it for me, but you're not all here with me, so we'll see how it works. So that is the volume of our cube. Okay? So now what are we going to do? Well, I'm going to figure out if the volume is between 600 and 800 inches, what measures of x would we need? Notice this is a parabola opening up. We already said the minimum x is going to be 6. Anything less than that, you'd have a negative volume, which doesn't make sense. Okay? If you don't like this sketch, what you can do is you can basically type this in your calculator, 7.5x squared. Go ahead and do that. Minus 63x plus 108. Let's see. 7.5 x squared. I lost it. What was it? Where did it go? Minus 63x plus 108. So minus 63x plus 108. We have a 0 here at 6. Okay. And the graph's opening upward. We probably should mess with the settings here. Let's go ahead and change the zoom. So our x, we're going to go ahead and start that at 6. We're going to go a little bigger than that, so let's go ahead and go to, I don't know, let's go to 30. The y, negative 1, probably going to get a volume higher than 12, so let's go ahead and go to like 200. See how that looks. Okay, so we went a little far on that. Maybe make the volume a little higher so we can see more regions. So 2, let's go ahead and go to like 2000. Window zoom, change that 200 to a 2000. That gives me a little more scale for what I'm looking for, okay? And, well, I think I might have an issue. Look at my x's. Zoom, settings, because we actually needed the x's between like 600 to, or no, the y's, that's right, from 6 to 800. So we should be good, actually. So somewhere in here, there's going to be a 600 and an 800, and we want to figure out what x's match that, okay? So here's our sketch. We have y values between 600 and 800. We want the x's that match that. So what we're going to do is we're going to take each of these equations. V is equal to 7.5 x squared minus 63x plus 108, and say what the volume were 600. 600 is equal to 7.5 x squared minus 63x plus 108. Well, how do we want to solve this? I don't really feel like running this through the quadratic formula, but I could. I could set this equal to 0. That would become what, minus, let's say 492 is what I'm getting. 492, 108, 5, 600. That should work. Okay. I could set that equal to 0, and I could run that in the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all divided by 2 times a. Now keep in mind, that's really only the first answer. They still need between 600 and 800, right? So the other option is then I'd have to do the same thing with 800 and say, well, 800 is equal to 7.5 x squared minus 63x plus 108. Subtract that over and go 7.5 x squared minus 63x minus, it would be 692 this time. Once again, run that through the quadratic formula. X is equal to negative 63 plus or minus the square root of b squared minus 4 times a times c all divided by 2 times 7.5. My hope is that we might be able to use some technology to make this a little easier. So what we can do with this, keep in mind, our calculator has kind of an ask function. So if I graph this, and I already did, okay, then what I could do is I could trace this and I could try to guess. Let's go ahead and mess with the table again. I'm going to add a split screen table in there, but this time in the settings, maybe, settings, move down, edit, settings, there we go. I'm going to change the y to ask. So what that means is that I can input a y and it should automatically communicate and calculate the x for me. Okay, that's weird, but we could do that. So the x's that, or the y's that we want are 600. That's not, I see this in what I want. Menu table, maybe this, I don't know if the calculator will do this for us, so let's see. Change it both to ask and see. What if I put a 600 in the y? Yeah, see, this isn't going to work. Try one more thing. I'm going to get rid of the table. Looking at the graph here. Analyze graph. Ah, there we go. See, here's what we're going to do. We're going to put 2 more lines on this. I'm going to put 2 more equations on here. How about 600 and 800? Like, why would I want to do that? Well, because now I can find out where the red equation, ooh, that is not what I want to do. I'm doing Control Z. There we go. I want to find out where this red equation crosses these 2 lines. So menu, analyze graph, intersection, red one, choose the black one, before and after, and there crosses 600 at about 13.3. I'm going to put that on my picture. So at about 13.3, we get about 600. Where does it cross 800? Well, we graphed that vertical line at 800, and so I can use technology to go menu, analyze graph, intersections of the red and the purple, a little before, a little bit after, and it crosses 800 at about 14.7. I'm going to argue that that's a little easier than running that whole thing through the quadratic formula. So you got options. You're going to have the technology. Yes, you should know how to use the quadratic formula. Yes, you should be able to solve these, but we have options with the technology to get these answers quickly and accurately. Just so I'm not completely BSing you, we are going to check it using the quadratic formula. So negative 63. Let's go back to the algebra here. We said x is equal to, I'm going to set up the equation here. So negative 63. I'm not skipping any steps. So we have plus or minus, so I'm going to do the plus first. The square root of, and being the negative b squared, so that would be negative 63 squared. but you have to make sure you keep the parentheses in the right spot. Minus 4 times A times C. So that's minus 4 times 7.5 negative 492. 7.5 negative, I should use negative 492. All divided by, don't you dare, all divided by 2 times A. Since I want an approximate answer, I'm going to hit Control Enter. Is that the answer we got? About 13.3, right? Why do we have plus or minus? Well, in the context of this question, x is equal to negative 63. If I put a minus there, dang it. Alright, I can outsmart the technology here. If I change that plus to a minus, that doesn't make any sense. We are not going to have a length of negative 4.92. Okay? So that makes no sense. There's our answer. I can do the same thing with the other. I just need to change the 492 to, what was it, 692? So if I take that top equation, rather than rewrite the whole thing, I'm just going to go to the 492 and change it to a 692. Go up there, grab it, drop it down, edit it. Control Enter. About 14.68. What did we get? Well, they rounded it up. So these are approximates, but we can use technology to get that pretty quickly and accurately. If I want the exact, yeah, we got to go back to the algebra, but both work. So if they really want it at the first decimal place, feel free to use the technology. If they need it more exact, feel free to use the technology with the quadratic formula. Doesn't change our answer.